Okay, so welcome back. And so what we're going to work on today is the beginning of what I call transformations. And what we're going to start with is what we call shrinking and stretching a graph. Okay, shrinking and stretching a basic function. So, and let me give you an example so you see what I mean. So we're going to use the absolute value function. So I've graphed the absolute value function, so this is f of x equal to the absolute value of x. So this is one of our basic functions. Okay. So we're going to talk about stretching and shrinking, and so what we mean by this is we're going to be multiplying a function either on the outside of the function or on the inside of the function, and a is going to be positive. Okay, so that's what we're doing. So we're either going to multiply the function outside, so we're going to multiply the function by some positive real number, or we're going to multiply on the inside of the function, or we're going to multiply x by a positive real number, and see how that affects the graph of the function. Okay? So let's start with the basic function, and so let's graph each one of these, and I'm going to graph them in a different color. So the first one I'm going to graph is this one. So what is this doing? What is it doing is taking every value of x that's inside the function and I'm doubling it. Okay? So in other words, if it's outside the function, I'm taking each of the y values of the original function and I'm doubling those y values. Okay? So let's see what this looks like. If I plug in values of x, so let's start with 0. Well, 0 times 2, well, the absolute value of 0 is 0. So that's going to just give me 2 times 0, right? So let's plot some of these. So what if I put in 1? Well, the absolute value of 1 is 1. 2 times 1 is 2. So I'm going to go from 1, 1. So I'm going to go to 1, 2 here. So this is going to plot 1, 2. Now let's plug in 2. Well, the absolute value of 2 is 2. 2 times 2 is 4. So now I'm going to go to 2, 4. And then let's do 3. So 3 is going to go to 6. And so what do I end up with is I end up with something that looks like this. And then if I do the same thing over here, negative 1. Well, negative 1, the absolute value of negative 1 is positive 1. So 2 times 1 is 2. So I'm going to get the mirror image over on this side. And so now this is y equals 2 times x, which I can also write as 2 times f of x. So what's it doing? Well, it looks like it's taking this function and it's stretching it, and it's becoming more narrow because it's being stretched in the vertical direction. Okay, so this is what we call a vertical stretch. Okay, now what if we do this? What if we take half of f of x? Right, so basically we're taking this function and we're taking half of it, which means now we're going to take these values and we're going to push down and make them half. So let's put in the value. So if I put in 0, of course that's not going to change anything, 0. If I put in 1, I'm going to get a half. So now let's do this in a different color. So this is going to be 1 and a half. Okay. And then 2 is going to go to 1. So 2, comma 1. And then 3 is going to go to 1 and a half. And then 4 is going to go to 2. and so on. And so I'm going to get something that looks like that. And of course, I'm going to get the same thing over on this side. And so look at that. So now this is y equals 1/2 of the absolute value of x, or in other words, 1/2 of the basic function. Okay? So now, what did I just show? Well, if I multiply by a value that's positive but less than 0, so here's the thing. So let me note here. So a here is bigger than 1, right? And here, a is less than 1. Okay? So if a is bigger than 1 and it's outside the function, it's a vertical stretch. If a is outside the function and it's less than 1, it's a vertical shrinking or compression. Okay? Now, what about if I bring it inside the function? Well, what happens now? Okay, well, now I'm taking each x value and I'm doubling it and then taking the absolute value of the product. So, what would that look like? Well, let's just put in the value. So if x is 0, then 2 times 0 is 0, and the absolute value of 0 is 0, so we end up there, okay? Okay, so let's do another one. So let's see here. If I do 1 times 2 is 2, and the absolute value of 2 is 2, so I get 1 comma 2. Well, look at that. 0, 0, if I put in 1, I get 2, 1 comma 2, I get the same point that I got there. And then if I do 2, 2 times 2 is 4, the absolute value of 4 is 4, so I get 2, 4, look at that, I get the same value that I got there. Okay. And if I go to 3, well, then that gives me 6. And notice that I get the same result here. So what's the point? Here, I'm multiplying on the inside by 2. And I end up with the same result that I got before. Well, why is that? Well, because in this case here, this, remember the properties of absolute values, I can write this as the absolute value of 2 times the absolute value of x, and of course the absolute value of 2 is 2, and I get the same thing. Okay, so in this case here, I get the same function because of the property of absolute values. Okay, and so I end up getting the same thing. Okay, but the main thing is here's the takeaway, is that if you're multiplying outside the function and a, the number that you're multiplying by is bigger than 1, then you're going to be stretching in the vertical direction. If the a value is less than 1, then you're going to be shrinking in the vertical direction. Okay. Okay, and I think, let's see here. Oh, so, and then the thing here is, in this case, I'm inside the function. So if inside the function, what does this turn into? Well, a is bigger than 1, and what's it doing? Well, I'm affecting x, right? So here, I'm affecting y, so it's in the vertical direction. Here, I'm inside the function, so I'm affecting the horizontal direction. So in this case here, even though I ended up with the same graph as I did up here, this is a vertical stretch. Here, this would be a horizontal shrinking or a horizontal compression. Okay, so we get the same graph, but for different reasons, if you will. Okay, so again, so now here's the thing. What if we made a less than 1? So let me just throw this up here. What if we do y equals 1/2 x and a is less than 1? Okay, notice something. This is a vertical stretch. This is a vertical shrink or compression. Here, this is a horizontal shrinking. This here turns into a horizontal stretch. Okay, so now notice something here. This and this, a is greater than 1, a is less than 1. When a is greater than 1 and you're outside the function, it's a vertical stretch. When a is less than 1 and you're inside the function, it's a horizontal stretch. Okay? So inside the function is sort of like opposite what you get with the vertical. So if you remember this, if you remember that, hey, if you're outside the function and a is bigger than 1, then it's a vertical stretch. If a is less than 1 and you're outside the function, then it's a vertical shrinking. Okay? Now if you're inside the function, then it's opposite of what we said for up here. Because if you're inside the function and a is bigger than 1, then it's a horizontal shrinking. If you're inside the function and a is less than 1, then it's a horizontal stretch. Okay? So that's the shrinking and stretching of a graph. And again, this was just based on just using the basic graph of the absolute value as a reference point to see it. Okay? And that's it. That's all I have for you. And next time, we'll go into the definitions of vertical stretching and shrinking, and then we'll talk about the horizontal stretching and shrinking of graph, and we'll put it all together as a definition. Okay. Have a great day.